Alright, so hi YouTube. Today we're talking about results and I'm going to do a quick one because I'm really tired. But um, yeah, this is it. So the last time we were doing our vector addition, we used the option enum in order to specify that, okay, we may not always have a successful result. Okay, we may not always have a successful result. What do I mean? It basically means that uh, depending on what vectors I supply, the vector 1 and vector 2, well, if the vectors are of different length or there's something wrong with one of those vectors, then we cannot have a valid result. In that case, the last time we returned the none variant of the option enum, meaning to say it's like a null value. Okay, so the option enum is one way of specifying that, explicitly stating that, our results may not always be valid. Okay, but one disadvantage of this approach is that you don't know what actually went wrong when you started your program or started your function. So this for this dot product function, a lot of things can go wrong. Maybe the vector lengths are different. Maybe one of those vectors contains not a number, NaN value, not a number value, or there could be a whole host of other problems as well. Maybe the vector has a length equals to 0. Then something is wrong as well. So in that case, the dot product for a vector of 0 length, where both vectors are of the same length, that is undefined as well. All of these are different things that can go wrong with this program, right? All these things are things that can go wrong with this program or this function, this dot product function. However, if we use this option enum, we are just returning a none value and we have no idea what actually went wrong with this function. Okay, so it is way more common in Rust that you use a different enum called the results enum. Okay, result enum Rust. Okay, so you will be able to find resources right here. Okay, what the enum looks like. So it's basically like the option enum. Okay, option enum. So the main difference is that, okay, for the sum value, the sum variant, this is what we call like the OK variant, right? We have a valid value and then we store that value inside here, inside this sum variant. Okay, for the result enum, the equivalent of the sum variant is called the OK variant. It means that your results are okay. Okay, for the option enum, if something goes wrong, we like to use this none variant. Okay, this none variant, meaning there's like no value down there. We use this none variant to specify that something has gone wrong and the value is this variable is now so-called invalid. For the result enum, we actually have this thing called the error type. Okay, the error type. And this error type is a type you can specify. It can be anything. Okay, this E is just a generic. This could be a float, it could be a string, it could be an enum, it could be anything. Okay, so you can stuff whatever piece of data you want in here, and you can stuff whatever piece of data you want in the OK variant. Okay, you can even stuff both of them to be strings. It's really up to you. So it gives you a lot more freedom. So the main advantage of the result enum over the option enum, okay, why would you want to use result? The main draw of this, the main advantage of using this result enum is that first thing first, you will actually know what went wrong with your code. You are able to store this information inside this error variant. Okay, there's a place for you to store that information. sometimes we can store it as a string. Okay, sometimes you can store it as a string, but as far as I've seen in Rust, it is sort of a better idea to store it as another enum. Okay, so what I've seen in some code bases online is that the error, okay, the enum, the error type is represented as an error enum. Okay, so this is a whole new enum which we store inside this result enum. So it's an enum within an enum. Okay, this is what you will see often in Rust code. So do bear that in mind. So let's start with a simple example first. Suppose that we have this dot product, right? We have this dot product and we want to replace this option enum with a result. So we can do that. I'm going to change this to result. Okay, and there are two things we need to supply. First is the type. Okay, first is the type of the OK value, right? First is the type of the OK type. So what kind of data do you want to store within the OK variant? That means it's equivalent in terms of concept. It's the same as this sum variant, right? So for this case, this t here will translate to this t right here. Okay, this t here will translate to this t right here, and for the dot product, the end result, the OK result is the float 64. Okay, a double value. All right. Then the other piece of information you need to supply is what is your error type. Okay, so if you look at here, you will see that the error type is a string slice. They call it. The nster is one of the string types you will find in Rust, and that's another topic altogether. But this is what we call a string slice. So basically a string. Okay, if you want to simplify it, a string is just some text and in double inverted commas, stuff like that. So this is what we call a string slice. Okay, but the other way, we can just use a full string. This is a string right here, a full string. So it's a UTF encoded string. It's the most common type of string. So I like to use this string. Okay, this kind of string, the one with the capital S. This is not a string slice. You should you should be aware that, okay, there are two types of strings in Rust. One is this string slice, and one is this well, I like to call it a full string, right? It's something that has a borrow. No, it's not a borrow, but yeah, it's just a string that it's like a. Can you see? Inside the string, there's a vector. There's literally a vector of U8. Okay. But never mind. This is the so-called string. Okay. And what we call an own string. But long and short of it, having a string around means to say you can actually store a piece of data in that string. Okay, you can store a piece of data telling you what went wrong with the error. Okay, what went wrong if there was an error. So you don't just get a null value or a none. You can actually return an error, and you can say, let's say for this case, we have a length mismatch between the two vectors. Okay, I can write a simple error message like the two vectors are of unequal length. Okay, so this is not quite done yet. For strings right here, for this kind of string, the one with a capital S, you actually have to well, you not only need to write this your string right here in open and close inverted commas. You need to use the toString method. Okay, so that's a little bit more troublesome, but that's how you work with that. Or that's how I have been working with that. It's a very simple way. Okay, and of course, instead of the sum enum, we should return the OK enum. Okay, so let's go through the code. What it's trying to do here before we edit the rest of our code, because there'll be some errors. Okay, First, if the vector 1 length is not equal to the vector 2 length, we give an error and say that, the two vectors are of unequal length. Okay, this is a string that we store in the error variant. Okay, the string that we store in the error variant. If it's okay, then we return the dot product value. Okay, so now let's change our expressions, because over here this doesn't work anymore. We are matching a totally different enum. Okay, so this enum, remember, it has two variants, right? So one is called okay, one is called error, and then we have a string, right? We have a string value. And then what we want to do is just to pass this. Okay, let's call this an error message. Okay, so we can pass this string value into the panic. Okay, yeah, we can pass this string value into the panic, and it's complaining that the formatting is wrong. So let's see what the compiler says we need to do. What we need to do is to just add this bit of code there, and our code should work. Okay, so let's add that in. Okay, and now it should work. And the nice thing about option and result is that the unwrap method, it works for both. So if what does the unwrap method do? It basically does what this piece of code is doing here. If the value is, if the enum is an okay, means to say that the code is running all right, then we pass back the value. Otherwise, we panic with the error message. So let's take a look at what the unwrap did. So you can see vector multiplication panicked at call result.unwrap on the error value. The two vectors are of unequal length. So the thing about the result enum is that if we unwrap it, at least we can store some information of what actually went wrong with our code, rather than just getting a none value, and then we have no idea what went wrong with our code. Okay, so that is the main advantage of having the result enum over the option enum. Okay, so the option enum is the option enum is just, how to say, a more specialized case of the result enum. You can think about it that way. Just that for the error type, there's literally nothing stored there. Okay, so this is how you'll often see code written in Rust, where we return a result enum if there is something that can go wrong with the code. So this is the result enum you often see in the code. Of course, generally speaking, it's a kind of bad practice. It's considered bad practice to return a string. Okay, a string in your error. Excuse me. Yeah, it's generally considered bad practice to return string and a string in your error. It's the most basic way. As you can see here, they use a string here in the Rust examples. Yeah, they use a string as the error type here in these examples, but this is generally discouraged. Okay, this is generally discouraged. So what you will see more often is that they will have another enum called the error enum that's being used in Rust. So let's have an example of how this thing is done. So you'll need to be familiar with enums if you want to do things this way. Okay, so I'm going to do a few things first. All right, I'm going to do a few things first. I'm going to add this crate called this error. Okay, so cargo add this error. Okay, and I'm going to do a cargo watch-x test. So this will build. And let me turn on my screen key so you will see what I'm doing in Vim. So this thing works quite nicely still because I have not added, and it compiles pretty nicely because I have not added anything new yet. So let's sort of make our new error type. Okay, so instead of using a string, we will use the error enums. Okay, so this is something you will see more often in Rust. More often in Rust code bases, you will see error enums. So this is considered a better practice or best practice rather than using strings. Okay. So one of the crates you will see is called ndarray linear algebra. You will use this sort of pattern. Okay, you will use this sort of pattern. So this is one example. You can go into this ndarray linear algebra. Go to source. Okay, I believe there should be an error. Yeah, error.rs here. If you look at the error.rs, you'll see that they will use this error, and this is called the linear algebra error. And you can see some examples here of how this is done. Okay, the ndarray linear algebra. This is I guess released. Where is it released? Okay, view license. Excuse me. That's the license. Oh, license.md. Okay, it's released under Apache or MIT license. So this is completely open source, so that's fine. And give credit to the linear algebra developers, ndarray linear algebra developers. So this is one example of a well-known crate relevant for simulation that uses this convention of this very common convention of errors. So do take a look at how this is done. It says here there are several errors. For example, like the matrix is not square, there's a lappec error, memory not aligned, so on and so forth. Excuse me. So what are the ways we need to get our error started? So this is the most simple. Okay, first thing first, after adding this crate, we will need to use this error crate. Okay, use this error crate. So copy that and paste it here. Okay, copy that and paste it here first, and then we need to create a public enum. Okay, so create an enum for the error. Pub enum. Okay, so what error is this? Maybe you just call it a dot product error. So name this error whatever error you like. So for this one, I'll just call it the dot product error. And then there are two things you need to do. Okay, copy this part, or two things you need to derive. Copy this part and paste. Derive both the error and debug traits. Okay, derive both the error and debug traits. If you're not sure what to do, just copy and paste this part. Okay, very simple. Just copy and paste this part. So remember over here, we actually had the two vectors are of unequal length, right? Okay, the two vectors are of unequal length. So how do we define that error? Okay, very simple. You can see that this error is right here. You need to have this error macro or whatever that thing is. Okay, the one with the pound sign. And then have this over your enum. So remember, normally enums are like this. You can just define it and then you store a piece of data within that. So, okay. Okay, so this error is as such. Okay, so this is the so-called error message. And there are a number of things you can do. So first thing first, let's just state our error type. Yeah, let's just state our error type first. Yeah, and so remember, for normal enums, you define your enums like this. For errors, it is basically the same, except that instead of just putting this different enum types, you need to put the error pound sign thingy on top of that. Okay, so first thing first, what could go wrong? What could go wrong with our code? First thing is that the vector lengths are unequal. Okay, vector lengths are unequal. So I'm just going to copy this whole thing here, or cut this whole thing and paste it here. Okay, cut this whole thing and paste it here, and it's really up to you whether you want to store something inside. Okay, for now I want to keep it simple, so I'm not going to store any piece of data inside here. I could put a string here, or if I wanted, but I'm not going to do that. Okay, I'll just put a comma down there. And let me put down there, instead of using a string, you use a dot product error. Okay, so this is a way more common way of doing things. So in this error, this error variant will be, you need to have a dot product error enum. So I'll just put dot product error vector length unequal right here. Okay, that's all. That's all you need to do. Okay, so okay, next is that we'll need to change the way that this code runs. Let me save this first. Oh, okay. In fact, actually, we don't seem to need to change anything. Our code still kind of works. So let's see. Let's see. Yeah, so if we do the panic and we use this thing, okay, here, all right. Just now we were having the match pattern, right? We have the OK that returns the value type, and the error with this error message. Well, as long as you put this error message within the panic in this panic macro, you'll be able to display out the error message. Now, this form of doing things doesn't just apply to strings, but it applies to anything that derives this debug trait. Again, let me say again. For panicking like this, you see putting things in this particular format. You have an error message, and then you have a panic with this so-called open and close inverted commas with open and close brackets. Right, this right here is usually to print out debug messages. Okay, it is used to print out debug messages, just like how I used it for the string just now. So that works, but this error message also works, or this dot product error also works because I derived this debug trait. Okay, that's what makes it work. Now, doing things like that, it is very helpful because I can do more than one type of error. Okay, for example, if let's say the vector lengths are, well, if it's unequal, it's one issue. If it's let's say vector length 0, right? Vector length 0. So I can put here vector length 0. Okay, I can put this right here. Either one of the vector lengths is 0. Okay, so for that you definitely cannot do a dot product as well. So let's do this. Let's do it like this. So I'm going to add the code here. If vector 1 dot length equals to 0, okay, return this thing, error dot product error vector length 0. Okay, this is how you can actually have multiple kinds of errors. Okay, additionally, if the vector 2 length is 0, length is 0, you can also return the dot product error, the vector length is 0. So what this allows you to do is that I can actually deal with different kinds of errors. Okay, I can deal with different kinds of errors. So that's really, really helpful. Right. So let's try having one of them with a 0 error. Let's try having one of them with a 0 error. So vector 2, I'm just going to clear out this, or rather, I'm going to clear out this whole vector 1 right here. Okay. And we'll call this dot product error handling 0 vector, because we cannot have two functions of the same name. Okay, and this one we'll call it dot product error handling unequal length. Okay, let's do that. So now let's take a look here. Indeed, when we when we do the unwrap, okay, we have a vector length unequal for one of the tests, and that is this test right here. We see the vector lengths are obviously unequal, and for this case, we have the vector length equals to 0, okay, and that actually gives the correct type of error, okay, the vector length equals to 0. Of course, we also can convert from errors. Okay, we can convert from different kinds of errors. For example, you see here, this disconnect error has this pound sign from. Okay, a pound sign from. So this from actually allows us to easily convert between error types. So we have this data store error. This is one of the examples here. We also have a non-dimensional linear algebra error. As you see here, the linalg error is of a different type. Okay, so this linear algebra error can actually, well, if you use this linear algebra crate and you happen to run into this linear algebra error, you are actually able to convert from this linear algebra error into whatever error you want using this from pound sign thingy right here. Okay, so the next thing about having errors is that you can readily convert between different kinds of errors. Okay, and that makes working with errors a lot nicer than working with strings, because when you work with strings, you will need to manually type a lot of information as to where this error is coming from, which crate is it coming from, so on and so forth. However, when you convert between errors like so, you can actually, as you see here, you can store one error type within another error, because both of these are enums, and you can store one enum within another enum. You can go as deep as you like. You can have a nested enum in that sense. And what that allows you to do is that, hey, you're able to have information that traces to the root of where your error is coming from. Okay, you don't have it in a string, you have it in a nested enum, that sort of thing. So probably I want to use another case study to revisit this, because this dot product is kind of a simple example. I don't need to have this sort of nested error, this so-called nested error that goes, how many layers deep, I do not know. But we might want a more complicated example in order to showcase how this error conversion actually works. So we might want to revisit this in some future video, but I'll stop the video for now. And I think, yeah, I'll probably go and rest, because I need to rest. Yeah, so I'll see you guys next time. Hope this was useful in helping you get your journey started into understanding what results are about. And that's all I have for you.